Well, if we look at it from the opposite perspective, the perspective that if late pregnancy is a bad time to look at membrane thickness, then the reverse of that would be equally true. Early pregnancy is phenomenal for looking at membrane thickness. In fact, the earlier membrane thickness is judged, the more accurate. And if you can get back far enough that you can actually see gestational sacs, then you can be right with almost absolute certainty. Okay. The reason for that is that gestational sac is a term that was invented by people that did ultrasound when I started doing ultrasound. We saw this ring inside the uterus, didn't know what the heck that thing was, but lo and behold, within a short time, we realized that patient was pregnant. So we realized that that ring probably was the gestation, and it got termed the gestation sac. But the correct term for this bright ring is the chorionic sac. So if there are two chorionic sacs, it must be dichorionic. So we see two embryos, twins. We see two separate gestational sacs or chorionic sacs. We can diagnose this with a high degree of certainty as dichorionic. Now here we see two sacs, but we see only one embryo. This has been termed the disappearing twin. It is something I have a lot of problem with as a physician. Now, we all report this as a twin pregnancy with an empty sac, and we fully realize that this will end up as a singleton pregnancy, but the mother knows it too, and she actually has to suffer grief of losing one of her twins when, under normal circumstances and under the circumstance that ultrasound didn't exist or wasn't done, she would never have known that. I have literally seen a mother tell her child that her sibling died in the womb, her twin sibling died in the womb because of this issue of disappearing twin. I really, really don't like disappearing twin. Now here we see two embryos, 1, 2, and we see only one gestation sac. So we can confidently diagnose this as monochorionic twinning. Now, because we can also see the amnions, we can diagnose this as monochorionic diamniotic. Now, I think you should be aware, I know you're all aware of the disappearing twin, but you should be aware of the appearing twin. When you and I see a gestation sac like this, we know it's too early to see the yolk sac, too early to see the embryo, so we don't know the health of the pregnancy. But without really knowing the health of the pregnancy, we do both think that's going to produce a singleton pregnancy. But if that is a monochorionic twin, then when the patient comes back, there will be two embryos inside of that single sac. So that's why this has been called the appearing twin. We all anticipate that we will, when we see that single gestational sac, we will see a singleton when the patient comes back, but it's not at all impossible to see twins when the patient comes back. This is more common than usually thought. The people at Harvard have done some very nice studies showing that appearing twin is not terribly uncommon and can even occur in multichorionic pregnancies because one tiny gestation sac isn't observed where the other tiny gestation sac is observed. Now, you could think back to our trilaminar embryo and realize that the trilaminar embryo lies between the amniotic cavity and the yolk sac. So if there were two yolk sacs, there should be two amniotic cavities. And by and large, that is overwhelmingly true, but it is not universally true. So you cannot use di-yolk-sacotic pregnancies as proof positive that it will be a diamniotic pregnancy. Nonetheless, that should be your anticipation, although it isn't your final diagnosis. You should confirm at a later time that it is indeed diamniotic. Okay, so here we are. We're scanning along tomorrow in our scanning labs, and we find this twin pregnancy, and we see there's a single placental mass. There's no question there's twins, and we want to find that membrane that very nicely, evenly divides this fluid, and this fluid is cc per cc, but son of a gun, I don't see it. I can't find it. So should we call the obstetrician and report a monochorionic, monoamniotic twin? And the answer is no. Obviously, the first thing we want to do under that circumstance is check gender. If one is a boy and one is a girl, it is dizygotic. If it is dizygotic, it is dichorionic. If it is dichorionic, it is diamniotic. And while all twins are high risk, that form of twinning is the lowest risk, whereas mono-mono is the highest risk. So we just took the highest risk pregnancy and converted it into the lowest risk twin pregnancy by simply deciding that one was a boy and one was a girl. Now, we checked the gender and it turned out to be boy, boy, or girl, girl. My next thing is to assume that the membrane is present, but it was inconspicuous. Why? Because that's what the literature and my very large experience with twins teaches me. The membrane is there, it's just inconspicuous. And why is it inconspicuous? Because it lies closer to one fetus than it does to the other. So these fetuses, you can find the membrane lying closer to this fetus than to this fetus. Why? Because twins don't share well. And this twin got a heck of a lot more amniotic fluid, and this twin got a heck of a lot less amniotic fluid than its co-twin. So they don't share placentas well. They don't share amniotic fluid well. This is not a circumstance of brotherly or sisterly love. Now I want to point out another thing, and that is that membranes specularly reflect. And here you see a place where the membrane is specularly reflecting and a place where the membrane is not specularly reflecting. If you don't understand specular and diffuse reflectors, by all means, as soon as this lecture is done, look it up, because that's an important aspect of ultrasound that can lead you to correct conclusions and mislead you into erroneous conclusions. And here is a circumstance where it can mislead you into an erroneous conclusion. You can see that this membrane is at least 2 times and possibly 3 times thicker in appearance than the actual membrane. So, if you only saw where the membrane was specularly reflecting, then you might wrongfully conclude that the membrane is thick when in fact it is thin. Now, sonographers, I want to caution you. You think every doctor is a dolt, and therefore when you take a picture, you know how important it is to get a picture of the membrane, and you want that membrane to be so obvious on the picture you take that even us dismal doctors could actually see it. So you actually have a propensity to take the picture where the membrane is specularly reflecting, and therefore you are doing your doctor a disservice, not a service. So my recommendation is that where possible, take the picture where the membrane is both specularly reflecting and not specularly reflecting, the doctor should interpret it here, not here, and you would have done the doctor a great favor. So there's no mistake possible. We can see both where it specularly reflects and where it does not. Now, you can appreciate that when the small volume of amniotic fluid goes to 0, which it very well can, this thin membrane will lie up against the torso and completely disappear.